Hi everyone. Okay, so I'm sorry I'm not with you guys today. I found out over the weekend my sister was coming into town, so I took the day off to get her from the airport and spend the day with her. So I'm doing this video on the intersection of two functions. Now, before you watch this video, you really should have watched the calculator tip video. You will need to know how to do those things on your calculator. The reason I'm doing the video this way this time is because I need for you to be able to see my calculator. I'm going to work problems out. I need for you to fill in your notes. I need for you to take good notes. If you need to stop, pause the video, whatever you need to do. We got a lot to get through. I know I talk fast anyway, so great thing about a video is you can go back and rewatch. Please do that, okay? All right, so we are going to be finding the intersection of two functions. Back in Algebra 1, you should have solved systems of equations. What that means is you were given two equations that were linear, and you could find the solution to both equations by graphing. There were other ways you could do that, substitution and elimination. But if you recall, if you graphed two lines, okay, I'm just going to do this right here. If I have a line A, okay, and I have a line B right there, that point right there, okay, x comma y, satisfies both of those equations. Okay, so if I have an equation for A and an equation for B, if I plug in x and y, it will work in both equations. Okay, so that is the solution to the system of equations. You're being asked to find the x-y pair, or the point, that satisfies both of those equations, and it will be where they intersect, okay? All right, we're going to do the exact same thing now, except instead of linear equations, guess what? We're going to do nonlinear. Now, we're going to solve this first one algebraically because I want you to see what's going on. So, as you see, we have an equation, let's see, absolute value of x plus 2 minus 3 equals 0.5x plus 1, and we need to solve for x. All right, so the first thing we're going to do is add 3 to both sides. Oops, sorry. All right, so the first thing we're going to do is add 3 to both sides. So we get x plus 2 equals 0.5x. If we add 3 plus 4. You see that? I added 3 over there. All right? Now, we have the absolute value here. Now, let's think about the absolute value for a minute. If I have the absolute value of, let's say, x, and I know that equals 4, okay? Then this x can either be negative 4 or it can be positive 4, right? Because the absolute value, oh, I'm sorry, can you see that? All right, so the absolute value of a negative number is the positive number, okay? So what we have to do down here when we're solving this equation is we say that x plus 2 either equals positive that or x plus 2 equals negative that. It's exactly what I just showed you up there with the 4. Okay, I said x either equals positive 4 or x equals negative 4. I did the exact same thing down here. Okay, now we're going to solve both equations. All right, so the first one we are going to subtract 2 right here, and we're going to get 0.5x plus 2. Okay, then we have to subtract 0.5x from both sides, right here. Subtract 0.5x from both sides, and we get 0.5x, because we have 1x over here, equals 2. So we're going to divide by 0.5, and so we get x equals 4. It's just a coincidence that I used 4 up here, you guys, and you got 4 down here. Just thought of a on the fly there. Okay. So over here we got to solve this one. Now, the tricky part here is you got to remember that that negative right there you have to distribute through the whole equation. All right, so now we're going to subtract 2 from both sides. Okay, and we get negative 6. Now again, this time we have to add 0.5 to both sides, okay, and we have 1 over here. So in this case, we get 1.5x equals negative 6. We're going to divide both sides by 1.5, okay, and this time we get x is negative 4, okay? So those are the two values of x that would make this true, okay? We could plug in 4 or negative 4, and that would be a true statement, okay? Okay, so that's how you would solve that algebraically. Now let's look graphically, okay? So if we let each side of this equation be a function, okay, so that's what we did right here. We said let f of x be absolute value of x plus 2 minus 3, and g of x equal 0.5x plus 1. What we're really asking is, when do these two things equal each other? That's exactly what we have right there. F of x equals g of x, all right? So that's what we found. We found that when those two functions equal each other is when x is either negative 4 or positive 4, okay? Now, how can we tell on a graph? Well, if you look over here, and I'm not gonna do this one on my calculator because I've done it already and I took a screenshot of it for you right there. Those are those two equations. The red one is g of x, okay, because that's a line, and the blue one is an absolute value, so that is f of x. So if we look algebraically at those two things, let me see if I can zoom in. Oh yeah, I can, cool. Oops, wait a minute, but I can't get my paper over there because of the way I've got this set up, which is kind of hilarious in itself. Okay, so there it is right there. So if you will see where these two functions intersect, right there and right there, okay? Look at my x values. This one's negative 4 and this one's positive 4, okay? So that tells us right there the solution to this equation right here. F of x equals g of x. What we just found up here algebraically, we found it graphically, okay? Now, let's look right here. When, let me zoom back up, there we go. When f of x equals g of x, all right, right here, so this is true when x equals 4 and when x equals negative 4, or at these ordered pairs, okay? Because right here, that is negative 4, negative 1, okay? And this point right there is 4, 3. So what I want you to notice about that is that the solution are the x values, all right? It's the x values, and we can actually say that the solution set for this particular equation is negative 4, 4. That's the solution set. Now notice I put them in braces. Now we've been talking a lot about notation. We had interval notation in our last lesson, which if you recall were the brackets. Okay, we have ordered pairs, which are parentheses. And we've talked about this. Remember those braces that everybody has a hard time drawing? Okay, that's set notation. Okay, that's set notation. That means a set of numbers, and it's a set of x values. Different from an interval, it doesn't mean that the solution goes from here to here. It just means it's these two numbers. It's a set of numbers, negative 4 and 4. All right? Okay, so let's see what this says. So when x equals 4 and when x equals negative 4 are both solutions. Let's see, x equals 4, that shouldn't be there. And x equals negative 4 are both solutions to the functions. Therefore, that is also where they intersect. Okay, so that also means both functions have the same value of y or f of x, okay, at these points. In other words, what we're saying is, in both functions, the y value at x equals 4 is the same, and the y value at x equals negative 4 is the same. which is here, 3 and negative 1. Okay, it's the same for both functions. If I were to take this, okay, and I would plug this x, 4, into my f of x right here, I would get 3. If I took 4 and plugged it into my g of x, I would get 3. That's what that means. All right? All right, so that's what we're proving down here. All right, so I'm going to quickly go through this. I'm going to evaluate f of x when x is 4. So when f of 4, I'm just plugging in a 4 where my x's are, okay? That equals the absolute value of 6. Don't forget that absolute value. You cannot leave that behind. So this is 6, and so this is 3, okay? If I evaluate g of x at x equals 4, we should get 3, okay? So I'm evaluating g of 4, and I'm plugging in a 4 where I see an x, okay? 0.5 times 4 is 2 plus 1, and it is also equal to 3. So that checks out. And now we're going to do negative 4 real quickly. F of negative 4 is negative 4 plus 1, plus 2 minus 3. Okay, this is negative 2. Don't forget that absolute value sign, because if you do, you're going to get the wrong answer. All right, so, I got to pull this chair up so I can sit down. All right, so this is positive 2 minus 3, and that's negative 1. Okay, and here we're going to do the same thing with g of negative 4. 0.5 times negative 4 plus 1, okay? So this is negative 2 plus 1, and again, this is negative 1, so it checks out. Now, I know I went through that quickly, okay? So if you need to pause right here to finish copying that down, please do. Otherwise, I'm going to go on. So for the two functions, f and g, what we found were two special ordered pairs that are points in the intersection of the graph. Okay, we found that. We found that they are solutions to a system of equations given by this and this, okay? And we found the value of x that satisfies that. Now, here's the thing. It's not always going to be 2 points. Sometimes it may be 1. Sometimes it may be 2. Sometimes it may be 3. In this particular case, it was 2. All right? So, here are some questions. Are the x-coordinates of the intersection points solutions to this equation? And when I'm talking equation, again, go all the way back up here to our original equation. That's the equation we're talking about. Okay, we're talking about the equation f of x equals g of x. Okay. Are the x-coordinates the solutions? Okay, the answer to this is yes, they are. That's what we found. Are the y-coordinates solutions? That is no, okay? They are not. Do you think there are any other solutions to this equation? No, they're not, okay? We graphed it. We proved that there were only 2. Alrighty? All right, so let's go on to page 2 of our notes. I need to find mine over here. Okie dokie. There we go. All right. So page 2 of our notes. Hang on, I'll straighten that up in a second. All right, we're going to do another one. We've got, this is actually a little bit different equations. All right, so solve the equation by graphing the two functions on your graphing calculator. All right, now, when I get down to here, I'll start putting them into my calculator to show you. But for now, let's just use, I've already done it and taken a screenshot for you. All right, so here we go. We see those two functions, all right. On my calculator, I have my first graph set up in blue. So this blue is f of x, and this g is g of x, okay? So these are the two functions. We see that we have 2 intersection points, there and there, all right? So from this graph, we see that. And it's on this graph, it's pretty simple because these happen to fall at very nice, neat points, okay? That point and that point, okay? We can see that the two intersection points are -4 and -3, right here. That's that point, guys, okay? And the other point is actually 8, 1. I'm sorry, 8, -1. That's that point. Now you could see this clearer on your calculators, but for this particular example, just trust me, those are the 2 points, and you could count over 1, 2, 3, 4, 5, 6, 7, 8, and down 1 right there. Okay? The fact that the graphs of the function meet at these 2 points means that when x is -4, both f of x and g of x are -3. Or, which really should be and, when x is 8, both f of x and g of x are, what do you think? -1. Okay? Thus, the expressions, these are my 2 functions, guys, are equal when x equals -4 or when x equals 8. All right? Therefore, the solution set, okay, we got to do those funky brackets, -4 and 8. All right? And that's what we're looking for. We're looking for the solution to those 2 functions. Okay, if you need to pause, please pause and make sure you get all of this down in your notes. It's really important, you guys, that you take good notes. I say that over and over again. Okay, so let's look at what's in this box. I'm going to move mine up a little bit. Got to get it straight. Okay. When solving equations by graphing, we are looking for values of x where the values f of x and g of x are equal, or the same. In other words, we want to identify points, f of x, and remember, f of x, remember, it's just our y. It's just the value of the function evaluated at that input, okay? So we're looking to identify the points x and f of x of the graph x and the points x and g of x of the graph g that are the same. This will occur when the graphs of the 2 functions intersect, all right? So I want you to make sure you understand why we are finding the intersection of these 2 functions, because that's a solution to those 2 functions being equal. It's the solution to the equation f of x equals g of x, okay? All right, so we'll set one side of our equation to f of x, and we'll set the other side to g of x, and then we will graph them, and we'll see what we get. All right, so this is where I've got to use my calculator. So I better stand back up, move my chair back, and, oops, sorry. What just happened there? Okay, so, all right, so here we go. We are going to graph these 2 functions. We're looking at number 4 here. We're going to graph f of x, and we're going to let that equal 2 times 1.5x, and we're going to graph g of x, okay? And that's going to be 2 plus 1.5x. Now, aren't you glad we don't have to do this by hand? Okay? All right, so I'm going to bring my calculator over here, and hopefully you can see that. Let me move this light away because that puts a little bit of a glare, and I want to move it up so you can see most of the buttons I'm pushing. Okay, oops, that's not it. Let's clear and clear. Okay, so I'm going to graph these 2 functions. Let's see if I can zoom in a little just to get those functions in there. Well, that kind of, you got to see what I'm doing. Okay, so the first one is 2 times, I'll zoom in once I get them in there, 1.5 to the x. Okay, there's my first function, and it's going to be in blue. And then I scroll down, and I do 2 plus 1.5. Now, you guys notice the difference between, hang on, between these 2 functions, okay? This one is an exponent x. This one's just multiplied by x. So make sure you get those into your calculator correctly, because you'll surely not get the right answer if you don't, all right? Okay. All right, so now let's graph them. You ready? Hit graph. Boop. All right, so it takes a few seconds for them to graph. There's my exponential, okay? It's exponential growth. And there's my straight line, okay? Now, you're gonna see, if you look at your graph, let's see if we can zoom in there, that we have two intersection points. There, about there, and about right there, okay? But this one is right on the axis. This one falls in between, so we don't have an exact point there. So I'm going to show you, and this is what is in that calculator tips sheet, show you we're going to find the intersection of these two functions on our calculator. So watch this. Okay, so I'm going to move this up a little bit. Here we go. All right, so I want to find the intersection of those 2 points. So we do second, trace, and you see where it says intersect, 5. Okay, so we put our little blinking cursor. Notice down here, all right, I'm going to zoom in again so you can see this. Notice down here it says first curve. So I'm putting this little blinker as close to I can to the intersection point. I'm actually working with my first function, which is right here, okay? So I put it as close to the intersection as I can. It just so happens it's already there. And I press enter. So then it's going to ask me to do the second thing with the second curve. Here's the thing, we're already there. So here we just need to hit enter again, and then it's going to say, okay, give me your best guess of that intersection. And there it is. So that intersection point is 0, 2. Okay, so I'm going to move my calculator, and I'm going to put over here, intersects at point, this is an ordered pair, so I'm putting it in parentheses, 0, 2. That's one of them. Now, let's go back over here, and we've got to find the next one. All right, so again, I'm going to do second, trace, intersect again, and this time I have to move using my arrow key. Here, I'm going to zoom in. Okay, using my arrow key to as close as I can to that intersection point. And then I'm going to hit enter. And then my second curve, enter. And then I'm going to say, give me your best guess. There it is. See, that is kind of a funny looking point. All right, but I'm going to write that down. Okay, so I'm going to zoom back in. Okay, so I'm going to write that point down right here. All right, so it also intersects at, I'm going to just give you about 3 decimal places, and let's see what they are. 2.776, comma, and my y is 6.164. Okay, so those are my 2 intersection points. Now, you guys, this is where I want you to understand. This is not the solution set, okay? My solution set are my x's, okay? So the solution to this equation, which you guys understand, we're just solving equations. As you know, we have moved on from solving equations like this. We've moved on from that, okay? We're doing much more complex equations like that. So we're finding x's that make this true. So my solution set are my 2 x values. So I put them in braces. Please do not ask me, Miss J, can we just put parentheses? No, parentheses are an ordered pair. That is incorrect. Okay, it doesn't matter which order you list those in, okay, because you're just listing a list of numbers. I usually put them in chronological order, but it doesn't really matter as long as you have the 2 in there. All right? Okay, let's go to the next example. Again, if you need to pause and think about that for a minute, please do. Okay, so we're going to now graph these 2 things on the calculator. All right, so let's bring our calculator back over here. All right, let's turn it on. We got to go back to y equals. We got to clear our last equations. Make sure you do that. And we're going to put in, what do we have here? X squared. Okay, and the absolute value, oh no, no, we're not at the absolute value yet. And 2 to the x. Okay, so there are 2, and we're going to graph. So here it comes up. It's a parabola, which you should know by the x squared. And you should know this is going to be an exponential. Now, this one is going, I'm going to tell you right now, is a little bit tricky. And the reason that's tricky is because there are actually 3 intersection points, okay? And it's hard to see that. I realize that. You won't be given a problem like this on the formative or anything, but there's a point, and then there's 2 over here, okay? And we're going to get as close as we can to those. Oh, no, I'm lying. I'm sorry. There's 1 here, and then there's 1 here, and there's 1 up here that you can't see. If I were to change my settings on my calculator, I would be able to see that one up there. All right, so, but we're still going to find them the same way. And let's find these 2 that we do see and see what we get. Okay, so once again, here we go. I've got to do, bloop, okay, second trace, intersect. Gonna get, let's do the easy one first, right there. Get as close as you can, where you think that is. Enter, enter, and guess. All right, well, there it is, right there. Okay, you see my x is about negative 0.7777666, so it's actually negative 0.8. But if you were to put negative 0.7667, don't forget to round correctly, that is absolutely fine. All right, so I'm going to put that here, and I'm going to write, actually, I'm going to put that here. All right, so these 2 things intersect at, and I'm going to put negative 0.767, comma, 588, about, okay? You can see that right there. Okay, 0.58, and then I'll round it up to 8, okay? All right, so now let's go try and find our next intersection point. Okay, we're gonna do second trace again, intersect. Now we're gonna move over to where about where it intersects, see if we can find it. Maybe about there, enter, enter, guess. Oh, nice. Okay, so that point is 2, 4. Okay, see right down here? 2, 4, intersection. Okay, so we're gonna write that right here. 2, 4. Now, you can't see that other one, but I'm gonna show you that it actually does intersect again, and it's gonna go, it's way up there, okay? So I'm gonna go way up there. I happen to know what it is, so I kinda know where to put my cursor, and there it is. It's at 416, okay? So it actually, boop, does it, okay? So my solution set is -7, we're just gonna say 77, comma, 2, comma, 4. See that? My X values are my solution set, okay? Oops, let me move over, sorry. Oops, right there. Okay, they're my X values. All right, again, if you need to stop, please stop and get this down, okay? There it is. Okay, last example, you guys. All right, now, so we're gonna go back over here to my calculator. Now, you should have watched the calculator video first. That would show you about absolute value and how to find absolute value. It's very simple, actually. So let's go, and we're going to graph. The first thing is absolute value of x. So to get to the absolute value, we do, let's see if we can move it. There, that's good. We go to math. Remember how we did math to find like this, and we found if we scroll down, we would find log base. Well, this time we need to scroll over to num, right there, num, okay? And you see that? Absolute value is the first one. Okay, so we just hit a 1 or enter, either one. And notice how it brings up my little absolute value signs. Okay, so we're doing the absolute value of x. Okay, and then down here we're doing x squared. Okay, and we're going to hit graph. Boom. So there we have, that's our absolute value. And then x squared is going to be a parabola. All right. So in this particular case, we actually have, 3 intersection points. Okay, we have one here, here. We've got one there because they both cross the origin, and we've got one there. All right, these you can actually see. You could actually pick these out on your calculator. This right here is actually -1, 1, This is 0, 0, and this is 1, 1. But I'm going to find them in my calculator just because I think we could use that practice. All right, so I'm going to do second trace, intersect, and I'm going to go over to there as close as I can. I'm going to hit enter, I'm going to hit enter, and I'm going to hit guess, and there it is right there. So there's my first intersection point, -1, 1. All right, so this intersects at -1, 1. Okay, so we're going to go find the next one, and we're going to do that with second trace, intersect, right there, hit enter, enter, and guess, 0, 0, which we knew, okay? So we're going to put 0, 0, and then we're going to do it one more time, second trace, intersect, here we go, let's go right there, enter, enter, guess, and there it is, right here. 1, 1. All right, so those are our 3 intersection points, okay? So my solution, or my x's, -1, 0, and 1, okay? -1, 0, and 1. That's my solution, okay? All right, you guys, that is the end of the notes. Trying to see, this video is 25 minutes long, but I think it will be helpful. You'll have it now. You do have a homework assignment to work on, so please refer to your notes, refer to the video, refer to the calculator tip sheet, and I will see you guys on Monday. Please have a great break, a nice 4-day weekend. Be safe, and I will be back on Monday. Bye-bye.